So in this video here, we're going to be talking about converting radians to degrees. To do that, we typically take the radians that we're given and we multiply it by a proportion. So in this case, 180 is the same equivalent as pi, is what we've learned. So if you're given radians, multiply by 180 over pi. For degrees, if you're given degrees first, all you do is take that proportion and you flip it. So pi is now on top and degree is on bottom. And you're probably thinking like, why do you switch them? Well, it's because when you have degrees multiplied by degrees on the bottom, the degrees signs cancel. And so basically, one of the things that you learn about conversion is that when you multiply something, you have to make sure it's the same unit on bottom that you're multiplying. So radians is being multiplied by pi on the bottom, whereas degree is being multiplied by the 180 degrees in the bottom. And that helps you convert to whatever is the unit on top. All right, so let me show you an example using the ones we have below. So like for part A here, let's zoom in. Oh, there we go. So this one here I have in radians, and I need to convert this to degrees. So once we convert it, we also need to sketch the angle on a coordinate system. So to convert this, we need to multiply it by, let me do it in blue here, by 180 over pi. Notice that I have the pi in the denominator because I want to cancel out that pi in the numerator. Remember, diagonals cancel each other, so when I multiply, this pi cancels out with this pi. I can also see if I can simplify anything else diagonally. Like what I notice is this 4 and 180, they're both divisible by 4. 4 is divisible by 4 one time. If I take 4 divided by 4, I get 1. Take 180 and divide it by 4, it is 45, I believe. 180 divided by 4 is 45. And so that leaves me with 7. And when you're multiplying, you multiply straight across with fractions. So 7 times 45 gives me, might need a calculator for this, 315. And then 1 times this pi got canceled. So this is just a 1 left. So 315 over 1 is just 315. And it's in degrees now because I canceled out the pi, so that just leaves me with degrees. And that's it. So to draw the picture here, I have it at starting at 0. Let's change this color to just normal green. And so my initial side is sitting at 0, and I need to swing this to 315. So remember, in degrees, this is 90 degrees, this is 180, and that's not enough. This here would be 270, and then if I add another 90 degrees, I'm back to 360. So my number is not more than 360. My number is between 270 and 360. So 315 lies somewhere in the 4th quadrant. Not that I need to say that, but I can see that here that this swinged all the way around to make that 315 degrees. So I'm in the 4th quadrant. And so I showed my picture using the coordinate system. All right, so let's try another one here in radians. So this one has 2 pi over 3. Again, you need to make sure you multiply by the correct proportion. So pi is going to be in the denominator since you want to cancel out that pi. And 180 is going to be on top because 180 and pi are equivalent to each other. From here, we're going to cross multiply, or in this case, cross cancel. So the pi's cancel. And 3 and 180 are both divisible by 3. So 3 divided by 3 is 1. 180 divided by 3 is 60 degrees. 2 times 60 is 120. And then 1 is left in the denominator, so I'm just going to carry that over. And so this gives me 120 degrees. That's my final answer. Now for the graph here, what that would look like is we're going to start at 0, then it's 90 degrees, and then 180. Now I don't really need to go past 180 because all I have is a 120 here. So 120 is between 90 and 180 degrees. So if I draw my initial side, which starts at 0, my 120 would be somewhere here. in the second quadrant. So there you go, that's our line graph. All right, let's try one that is in degree form already, and we have to change it to radians. So like in part C, we have 135, and we have to change it to radians. So this time around, you're going to have the 180 in the bottom because you want the degree signs to cancel, and then pi in the top. So this is going to be pi over 180, and we're going to multiply. And so if it makes you comfortable, you can put the 135 over 1 if you want to see how to try to cancel this or cross multiply. So when I look at this here, I can see that these two numbers are both divisible by 5. If I take 135 and divide it by 5, I get, getting my calculator out here, 27. If I take 180 and divide it by 5, I get 36. Okay, so I'm like trying to reduce this down as much as I can. So I have 27 times pi, so now I have 27 pi on the top, and I have 1 times 36 on the bottom, but I can still reduce 27 and 36. They're both divisible by 9. 9 divides into 27 3 times, and 9 divides into 36 4 times. So this is truly 3 pi over 4, and I can't reduce that any further. So this here is my angle in radians form, not in degree anymore, because notice I have a pi there, so this is in radians. Now to draw this coordinate system, I start at 0, then next is pi over 2, and then pi. Let's see if that's enough. So 3 pi over 4, if we mentioned this last time, pi over 2, if we were to make it the same denominator as 4, that would be 2 pi over 4, right? That there represents a half a pi. So when I look at this, this is 2 pi, this is 3 pi. It's not enough. It needs to keep going. This is a pi, but we can always write a pi as a fraction, and this would be like 4 over 4. So 4 pi over 4 is still a 1 pi. So this is a 4 pi, this is a 3 pi. So this is less than 4 pi. So it's somewhere between the second quadrant here. So my initial angle starts at 0, and then I'm going to swing on over to the second quadrant, and this here would be where my 3 pi over 4 would lie. So remember that your angle shouldn't be more than where it hits. All right, so for our next one, last one here is negative 60. So again, we're going to have to convert this first. So we're going to multiply it by 180 is going to be in the bottom, so that way the degrees match up. And then pi is going to be on top. And so if we multiply, I can put this over 1. 60 and 80 are diagonal of each other, and they're also divisible by 60. 60 divides into 60 1 time, 60 divides into 180 3 times. And then from there, I can multiply straight across. So that's a negative 1 times pi. So negative 1 pi. 1 times 3 is 3. So this is negative 1 pi over 3, or you can say that this is negative pi over 3. That 1 there is just a coefficient for pi, and it's a little redundant. So I'm going to get rid of it. But I need to graph this as well, so let's start with our coordinate system. So 0, pi over 2, pi. Okay, let's see if this is enough. So pi over 3, I know in math that 1 over 3 is definitely less than a half, right? Like think about measuring cups for a sec. A half a cup is much more, or a little bit more than a third of a cup. So in this case, I know it has to be between 0 and pi over 2. But here's the thing you guys might not have noticed. This is a negative sign. So this is not going counterclockwise. It's going to be going clockwise. So let's draw our initial angle here at 0. And so instead of going this way, we need to go the other way, the counterclockwise position, because it's a negative pi over 3. So if I look at this, here would represent negative pi over 2 because we're moving in the clockwise position. So this would be negative pi over 2. But I just need pi over 3, so that's somewhere in between 0 and negative pi over 3. So somewhere here in the fourth quadrant. And there we go. There would be my graph. So thought I'd show you what you would do if you had a negative radians. And that's it for this video.